All right, hello Algebra 2. We are multiplying radicals today. So again, we still need to be able to simplify radicals. So everything builds on those perfect squares. And so just to review, what are our perfect squares? One squared is one. One is a perfect square. 2 squared is 4. So remember, we're doing 2 squared equals 4. Another one. 9, 3 squared, 16, 25, 36. That's 6 times 6. 7 times 7 is 49. 64. Skipped one. 64. That's 8 times 8. 8 squared. 81, 100, 121. 11, 12, 144, and 13 is 169. So all of these are perfect squares. 13 squared is 169. 8 squared is 64. And when we take the square root takes us back to the root, which is 8. The square root of 121 takes us back to the root, which is 11. Okay, so really important that you understand the square and the square root cancel each other out. Really cool. So we have IXL M10 today, and it is multiplying and simplifying. Kind of nice. Today is really short and sweet. So example 1, we are multiplying. Write your answer in simplest form. And this is the tricky part for IXL. It must be in the simplest form. So you have to look for those perfect squares. So what we're going to do first is we're going to go ahead and distribute as necessary. So we're going to go ahead and multiply. Radical 2 times regular 8 is 8 radical 2. It's kind of like x times 8 is 8x. They just sort of get stuck next to each other. So this is 8 times radical 2. Here, these are both radical numbers. So radical 2 times radical 3 becomes radical 6. So since those were both radical numbers, they get multiplied underneath the radical. So be careful there. Do they simplify? That's the question we need to ask ourselves. And to do that, we need to look at the radical. This 2 is prime, and 6 only has 2 times 3, so there isn't a perfect square in there. And so we can't do any simplifying, and so this is the final answer. Kind of nice when that happens. Use blue, I like it better. All right, here we have negative radical 3. We're going to distribute it to both terms here in the binomial. So negative radical 3 times 3. Do they multiply underneath the radical, or do they just get stuck together? These guys stick together. So negative 3 radical 3. Here, they're both radical numbers, so they can actually be multiplied. So we have negative times positive, which is a negative result. Radical 3 times radical 7 is radical 21. And again, the question is, can you simplify this? Well, 3 is prime. It's just 3 times 1. And 21 is just 7 times 3, neither of which are perfect squares. So because we don't have any perfect squares in there, I can't do any simplifying. So again, we're just looking for perfect squares. Look for perfect squares to simplify. Really important, because that's where you're going to miss things when you're doing the IXL. All right, here we're going to distribute the radical 2. So again, radical numbers you can multiply. So that becomes radical 14 times 2 is 28. There we go. And then here, radical 2 times 4 radical 6. We're going to multiply the radical parts together. So we get positive. The 4 stays the same. Radical 2 times radical 6 becomes radical 12. And now we think, can I simplify? And I absolutely can on this one. So radical 28, we know is, oops, I didn't mean to do that. 7 times 4. So radical 4 times radical 7. And what is the square root of 4? 2. So we get radical 28 turns into 2 radical 7. And then here we have 12 under the radical. It has a 4 in there. So radical 4 times radical 3. And what is the square root of 4? It becomes 2. So radical 12 becomes 2 radical 3, but don't forget about the 4 in front. So that's 4 times 2, which becomes 8 radical 3. And then so we have 2 radical 7 plus 8 radical 3. Can that be simplified at all? No, those are not like radicals, so they just stay like that. Okay. Here we have binomial 2 terms times 2 terms. Binomial times binomial. So this is going to be that like super distribution. So I'm going to start with radical 35. Wow. 91? Lord have mercy. Okay. I'm going to need a calculator, I think, for this. First, I'm going to start by doing first times first here. Radical 35 times negative radical 5. All right, well, that's going to be radical. It's got a negative in front, so negative radical. I don't know what 35 times 5 is. Oh, I think I do. Wait, is it 105? Let me see. 35 times 5. 100. Wow, I was off. 175. Okay. Now I'm going to do the outside product here. Radical 35 times negative radical 91 is negative radical. I have no idea. That is where calculators come in handy. Oh my God. 3185. When I see numbers like this, I just kind of wonder if I had a typo. All right. That's okay. It ends in a 5, so I know it's divisible by 5. $637. I know is divisible by 7. 91. I'm trying to see if there's any perfect squares in there. I can't remember if 91 is prime. Look at that. It is divisible. Okay, wow. 3185. 3185 is divisible by 49. Look at that. Whoops. 3185 is divisible by 49. And I just kept dividing by numbers I knew. Like I know that 35 is 7 times 5. So when I multiply those together, this also has to be divisible by 7 and 5. 91, man, that is a crazy number. It's divisible by 13. All right, let's do now, we got to distribute this negative radical 7 to both terms. So my inner terms here, negative radical 7 times negative radical 5. Negative times negative turns to positive. Radical 7 times radical 5 is radical 35. And then negative radical 7 times negative radical 91 becomes positive. And again, 7 times 91, radical 637. Again, so keep your calculator handy. All right. Now, these are definitely large numbers that have to be simplified. So we're going to do that. First, I know this ends in 75, which means it must be a product of 25. So let's see. 175 divided by 25 is 7. So this is radical 25 times radical 7. And of course, the square root of 25 is 5. So that becomes negative 5 radical 7. Now, 3185, just to walk you through this process, I knew it ended in 5. So it had to be divisible by 5. And it also had to be divisible by 7 because I multiplied by 35. It's divisible by 35. But then I noticed, so let me go ahead and divide it by 35. We know it's 91. Well, 91, I'm thinking of things that give me a 1 in the ones place when I multiply. And I was thinking like 7 times 3 is 21. So maybe it was divisible by 7. And it was. So it was divisible by 7 there and divisible by 7 there, which is 49. So let's see, 3185 divided by 49 is 65. So radical 49 times radical 65 is how that splits apart. 65 is divisible by 5. I just want to make sure. Yeah, so 5 times 13 is 65. Those are both 5 times 13 doesn't have any perfect square numbers in there. Those are both primes. So that 65 doesn't simplify anymore. Square root of 49 is 7. So this becomes negative 7 radical 65. 35 is 5 times 7. Again, those are primes, and they're not perfect squares. So plus radical 35 stays the same. And 637, I knew, has lots of 7s. So I'm going to divide that also by 49. There we go. So radical 49 times radical 13. Pretty interesting. Knowing that 91 is 13 times, what was it? 7 is really helpful. All right, so here we have the square root of 49. The square root of 49 is 7 radical 13. Now the question is, are there any like radicals? And there aren't. So this is the final answer. If there were like radicals, then we could add them together. This was a really hard one. So use your calculator. Remember, special little tricks. If it ends in a 5, it must be divisible by 5. And if you can divide by 5 twice, then you can also divide by 25. So keep that in mind. Really interesting. Those are crazy numbers. All right, ladies and gentlemen, that is it. Good luck on M.10.